Everyone. Thank you for attending this presentation. My name is Caroline Chiquet. I've been working on this project for 2 years with Professor John Dover and Dr. Paul Mitchell of the University of Staffordshire. This project is all about green walls, and I'm going to present more specifically their impact on the animal biodiversity and their environmental values in the urban areas. We are going to look at, firstly, what's a green wall, their impact in the urban environment in terms of, as I said, environmental values, and more specifically, their influence on animal biodiversity. We're also going to look at how they can improve human well-being and have an impact on the particulate pollution. We'll also see what we're working on at Staffordshire University, our study sites and our lines of inquiries. And I will give you some information about the Green Wall Research Center. So firstly, what's a green wall? I am sure that most of you are familiar with green walls, so just bear with me a second so I can describe what it is for the others. It's a wall, funny enough, either freestanding or part of a building, partially or completely covered in vegetation, and that can be constructed outdoors or indoors. So you can use a green wall as boundary demarcation, as exterior house, office, or industrial wall. They also can be decorative wall, like herb walls, or indoors. They can be used indoors as room demarcation. They vary considerably in construction and have been divided into two main categories: green facades and living walls. So first, green facades are made of climbing plants, either growing directly on a wall with no additional infrastructure. So that means they are self-adhering climbers, such as the common ivy, for example, the Boston ivy or the Virginia creeper. Or you can also use specially designed supporting structures like stainless steel trees, meshwork, or cabling that will be used as plant support and for creating a gap between the building wall surface and the plants. The plants will grow up on the side of the building whilst being rooted in the ground or in containers. Here are some examples of green facades. So those ones are made of English ivy, wisteria, or Boston ivy, to mention only a few. Living walls on the other side, here's an example of an outdoor one, are composed of modular grid of wall panels, often made of polypropylene plastic containers or geotextile, like metallic cages, plastic rats, rock wool, plastic tubes, felt layers, etc. They can be attached to the building or be freestanding, and they can be retrofitted to an existing facade or directly installed on a new construction. This is an example of a freestanding wall with an integrated pump. The routing of a living wall is directly on the supporting structure, as you can see here. It is set on a growing medium that can be either conventional soil or not, with an hydroponic-fed nutrient delivery irrigation system that can be in closed circuit, like in this example, or not in closed circuit. There are 3 basic types of growth media, and because of this, it is possible to grow almost any type of plant. Here you've got the example of a living wall at l'Univers de l'Espace in Toulouse, France. It's an example of an indoor wall that has been installed when the building was constructed, so it's really part of the building. This one has been retrofitted to an existing building. This wall here is used as a vertical garden, so here specifically an herb wall. You can imagine how useful it is to have your herbs, lettuce or strawberries at arm's reach without having to bend. This wall is a freestanding wall, and it's used to create a demarcation in the open area. Those 2 pictures just give you an example on how big a living wall can be. So this one is an indoor living wall in an office in Stockholm. And this one is an obviously outdoor living wall at the Museum Quai Branly in Paris, and has been installed when the building was constructed as living features. So green walls, as with other green infrastructures, can deliver many human and wildlife benefits. They can enhance the biodiversity in urban areas, which has been shown to have measurable human benefits, both physical and psychological. And there are so many interactions and links between the different components that it's really interesting to study. Some of the benefits will come from the inner structure of green walls and might depend on the type of the supporting structure. And some benefits, on the other hand, will be provided by the type of vegetation selected, which means that you really can play around what you want to achieve and how you want to achieve it. We're going to see this a bit more in details now. So green walls have been shown up to now to mitigate the local climate in terms of temperature and relative humidity through heat island reduction. They reduce the stormwater flow by up to 80%. They also can reduce the acoustic and the light pollution. That's okay. They contribute to building insulation by increasing the thermal performance of buildings. Basically, it means that they can reduce the energy cost by providing summer shade and winter protection. If you take the example of green facades, deciduous plants on the south side of the building will work well in temperate climates. They will be screening the unwanted summer sun, but they will allow winter sun to warm buildings and provide light. Whereas evergreen plants that will grow on the north side of the building will be screening the summer sun, but most importantly, they will improve the thermal insulation in winter. They also can work and act as a building bioprotector, especially a green facade. They will so act as bioprotection from agents of deterioration like frost, direct solar radiation, rainfall intensity, etc. Usually people will think that a climbing plant like ivy growing on the facade will damage it, but in fact it is quite the contrary. If the building has a bad mortar, yes, the ivy might damage it, but otherwise it's been proven to actually protect it. The animal biodiversity of green walls. So I'm sure I'm not going to surprise any of you by saying that a plant attracts insects and other invertebrates such as snails to feed on their nectar, their pollens, or their leaves. The latter in turn will attract predators such as spiders, birds, or small mammals. So green wool in fact as primary or secondary food sources. They can protect against bad weather or predators, and they can be also used as habitat corridor, which means they enhance the connectivity between different green spaces from the biotaxa. They can also act as barrier or refuge for many species. Depending on their size, structure, and vegetation, they will promote certain species according to their traits, and that means that it is possible to favor specific animal species or groups by selecting specific characteristics. So basically, you can design a wool that will attract more butterflies or honeybees, or that will be good for bird feeding. As we've just seen on the previous pictures, green walls and especially living facades dramatically improve the urban scenery. They can cover huge heights. So the current tallest European green wall is 33 meters high, which is pretty amazing in terms of physical constraints. And almost any plants can grow on them. So the diversity of available plants, and so foliage, colors, volume, textures, etc., permit the design and the construction of various patterns and shapes. I don't have a picture to show you that, but some companies actually use green walls on their main facade to design their logos, which I found pretty great. As we already saw, plants are associated to many human benefits. They improve attention among children, the recovery following operation in hospital, or they reduce stress and enhance work performance in the office. As plants can be used at different heights on living walls, it's also possible to use them as vertical garden by growing vegetables and fruits, so lettuce, raspberries, etc., in areas where space is costly, like a flat, or by disabled people unable to bend down or in a wheelchair. Another interesting point is that the plants improve the air quality through trapping pollutants coming from the traffic or the industry activities. They can therefore reduce the amount of nitrogen oxide, ozone, or heavy metals. PM10 especially, particulate matters that are less than 10 microns in diameter, which means they can reach far into the lungs, are of massive interest because of their involvement in respiratory disease. The reduction of PM10 level is actually a focus of policy for the Department for Transport and the Department for Environment, Food and Rural Affairs. So it is something under the spotlight currently. Having said all that, as you can see, the benefits of green walls are quite broad and little research has been done on them so far, really. That's why we decided at Staffordshire University to study them and to focus on the differences between climbing facades and living walls. We are study sites, so we are actually working on different types on existing green wall that has been established since many months. So we've got climbing facades on Stoke-on-Trent and Newcastle-under-Lyme. So here's an example of a walled ivy wall that we're comparing with small and well-maintained ones to look at the threshold in terms of efficiency and impact. That's another big one. That's a smaller one. That's a wisteria wall. We also study different commercial systems in Birmingham, London, and in the London area. This is an A&S Cutscape living wall in Birmingham. This one is a Scotscape living wall again in London. You can see that some nice water features under it. This one is a biotexture wall in a tube station in London. And as you can see, all the plant designs are very different on every wall, and you really can do whatever you want. Here, for example, you have some lavender walls. This is a private garden in London. It's a wall from a company called Treebox. That's another biotexture wall. And this is another Scotscape wall. Here, this device is called the Vortis suction sampler, and I'm going to detail the use of it soon. So that's another living wall at the King's Fund Trust in London. This one is another living wall from Treebox. So we've been and we're studying all those established green walls, but we also wanted to survey new walls in order to assess some other characteristics, like for example, how quickly do vertebrates and invertebrates start using a green wall? So how long does it take before they actually colonize it? What are the first species to arrive, etc. So for this purpose, Staffordshire University acquired a living wall from Mobile, a Dutch company, and we planted flowering and non-flowering plants in order to evaluate the impact on animal biodiversity. So here you can see the different patches. The main objectives of our project are to investigate the value of green walls as invertebrate and vertebrate habitats in urban areas. So for this, we're using visual searching and capture, Vortis suction sampler. So that's the device you've just seen, which is basically a big hoover that is able to suck from big snails to bees or really little flies. We're also using spider web counting and characterization with identification in the lab with light microscopy and identification keys. We're also looking at the impact of green walls on aspects of urban pollution, like particulate capture by leaves and steam. So through atomic absorption spectrometry and environmental scanning electron microscope. So those devices are used to establish the size and the chemical composition of particles that are tracked by the plants, and also the impact of the plant's physiology, the impact of the particulates on the plant physiology, so through photosynthesis activity measurements. The purpose of this act is to establish how the plants trap dust. So what fraction of the suspended particulate matter they actually remove from the free air, and how this capture have an impact on the plant growth. So basically, you want to find the perfect plant, the one that looks dashing because of its unusual foliage or for the length of its flowering period, and at the same time the plant that can capture particulates really efficiently without dying in the process. So if you've got a great plant that catches ivy beetle but died 2-3 months later, that's not so good. We are also looking at the value of vegetation to building and the impact of the different commercial systems. They all use different materials. For example, one is made of rock wool, the other is made of plastic racks, directing the plant 45 degrees, while the other will direct the plant vertically. So how this affects their influence. Let's have a look at some results of our preliminary studies on green facades. So if you take the mean bird abundance during morning surveys on summer or winter and different type of foliage, so bare equal no vegetation, deciduous foliage like wisteria or evergreen foliage like ivy, whatever the season of survey or the type of foliage, you can see that you've got more birds observed interacting with green wolves and its immediate area compared to bare wolves. So during the survey, during the survey in summer, there's no significant difference in the number of birds found on green wolves with evergreen foliage compared to deciduous foliage. Whereas in winter, you can see that there are really more birds associated with evergreen plants compared to deciduous plants. They will be like really significantly more abundant. So our preliminary study showed that birds clearly exploit the vegetation covering walls, and it is specifically to be most value for birds in winter, and it's presumably more the evergreen species because they can provide shelter and refuge, like acting as a source of heat or providing a perch board protected from the wind when deciduous green wolves have lost all their leaves. Moreover, evergreen species such as ivy can provide a supply of fruits to birds in the cold season, like with berries, for example. Concerning snails, so on this graph, you have the mean snail abundance on green wolves per season, found with two sampling methods, so the visual searching and the vortisection sampler. We analyzed the seasonal differences by comparing snail abundance on the wolves sampled in autumn and summer. Among green wolves sampled by visual searching, snails were significantly more abundant in summer than more abundant in autumn than summer, whereas it's the contrary on the vortice. And our preliminary study showed that the type of sampling method actually have an impact on the cold species. So the vortice method actually catches mainly small species, whereas the count in situ survey big species. We also highlighted the fact that green wolves can be used as habitat or as short corridor between different green spaces in urban areas by snails. This project is a PhD that will end in a few months, but the end of the PhD will be the end of the research project on green wolves at Staffordshire University. We want to create a green wall research center where would be carried different study with a main focus on the impact of green walls on building and animal biodiversity and on the particulate pollution. Currently, we already have different types of green walls on the campus, so different ivy species freely growing on walls. We've got climbing plants established on different aspects using covered supports. We have a huge range of evergreens, and we also have a living wall using rock wool panels. We are aiming to go for a wider range of green walls on campus, but also to continue surveying different sites in UK in partnership with different commercial companies. So in conclusion, we can say that green walls have the potential to bring many environmental benefits to urban areas. However, there is currently still an information deficit, which makes it really an interesting cutting-edge research. Growing plants vertically, so as green walls, whether as independent structures or directly on and in building, uses largely underexploited vertical space, which interests urban areas where space is costly. They also allowed an additional type of ecosystem to be incorporated into the urban environment, which has considerable benefits to humans. So thank you for your attention. If you have any questions on what we've just, if you would like information on my work on the Green Wall Research Center, just feel free to get in touch at c.chike@staff.ac.uk. Thank you.